Very well. Let us continue and start chapter 8. In chapter 8, we're going to talk about techniques, shortcuts to take the integrals. So let's write down some important integrals that you learned before. For example, if you have a constant like k, the integral of k is equal to k times x plus constant of integration. If you have a power function, x to the p, dx, the integral is x to p plus 1 over p plus 1 plus constant of integration. If you have, for example, the integral of, let's see, cosine of ax dx is equal to sine ax divided by a plus c. If you have the integral of sine ax dx, this is negative cosine ax divided by a plus constant of integration. If you have the integral of, let's see, secant squared ax dx, this guy is equal to 1 over a tangent ax plus c. You can find all formulas on page 1 of 8.1. For example, if you have the integral of dx over x, it is ln of absolute value of x plus c, and the rest of them. So you learned about these integrals before, using use substitution, using antiderivatives to find the integrals. In this chapter, we're going to go over more techniques to learn how to take other integrals. For example, suppose the question says, show that the integral of tangent ax dx is equal to ln of absolute value of secant ax over a plus constant of integration. So on the left-hand side, you have integral. On the right-hand side, you just have an expression. To show this equality, we take the derivative of both sides. Very well. The derivative of integral, as I mentioned before, they are opposite of each other. You can intuitively see that they cancel out each other. So the derivative of integral of tangent is just tangent ax. On the right-hand side, you are taking the derivative of ln. So here you have ln of absolute value of secant ax divided by a, and the derivative of constant is 0. So our goal is just to take the derivative of right-hand side and show that it's equal to tangent ax. First of all, here you have 1 divided by a. You can take this coefficient and write it in front of the derivative. So here you have 1 over a. Now you take the derivative of ln. The derivative of ln, so it is secant ax. Before writing this right down, let me simplify this for you first. Secant is 1 over cosine. So you can write this as ln of 1 over cosine ax, and here this ln of 1 divided by is ln of 1 minus ln of cosine. So this is actually, let me take it 1 over a ln of 1 minus ln of cosine ax. We make it easier for ourselves. Instead of taking the derivative of secant, now you only have to work with the derivative of cosine, which is much more easier to deal with. ln of 1 is equal to 0. Here you have 1 over a. The derivative of cosine, you already have a negative sign in front of it, is negative a sine ax divided by, and then you're taking the derivative of ln, you have to have cosine ax down here. Very well. We can cancel out negative, negative, a and a. We get sine ax divided by cosine ax, which is equal to tangent ax. So we show that left-hand side is equal to right-hand side. Okay, let's move on to page 2. Page 2. So, question says evaluate the following integral. You have the integral dx over e to the x plus e to minus x. What I'm going to do, I'm going to simplify this rational function first. So I have 1 over e to the x plus e to minus x, which is 1 divided by e to the x plus 1 over e to the x. This guy is equal to 1 divided by e to x over e to x times e to the x plus 1 over e to the x. I'm going to take the common denominator between these two, which is equal to 1 over e to 2x plus 1 divided by e to the x. So I can flip this. I get e to the x divided by e to 2x plus 1. So my integral is now the integral of e to the x dx over e to 2x plus 1. Very well. I have e to 2x. So this guy is equal to the integral of e to the x raised to the second power plus 1 times dx. So I have e to the x down here. Take a look at this. Let u be e to the x. I'm going to use a u substitution. du is equal to e to the x dx. The derivative of e to the x is e to the x dx, which is up here. This is my du. So my integral is now equal to the integral on the numerator. I have du divided by, on the denominator, I have u squared plus 1. But what is this integral? Du over u squared plus 1. This is inverse tangent of u plus constant of integration. What is u? U is e to the x. So this integral is equal to inverse tangent e to the x plus constant of integration. another example for you. So question says, evaluate the integral of cosine x plus sine cube x divided by, let's see, secant x dx. Very well. Let us simplify this integrand here inside the integral. This is equal to the integral of cosine x divided by secant x plus sine cube x divided by secant x dx. So what was the definition of secant? So what was the definition of secant? Secant is 1 over cosine. This is the integral of cosine squared plus sine cube cosine x dx. Okay. Now you have to take the integral of cosine squared and take the integral of sine cube cosine x. This one is easy because it's just u sub. For this one, you have to get back to pre-calculus. Cosine squared is equal to 1 plus cosine 2x divided by 2. So this guy is equal to the integral of 1 plus cosine 2x divided by 2. Let's separate these. Integral of sine cube cosine x dx. To take this integral, we can write a half in front of the integral of 1 plus cosine 2x dx plus. To take this integral, we can use u sub. You can say that a by u is equal to sine x, so du is cosine x dx. We get u to the third du. This is written. So here we have a half. Integral of 1 is just x plus the integral of cosine 2x is a half sine 2x plus the integral of u to the third is a 4 u to the 4. But what is u? U is sine x. Now we can just distribute a half. We have x divided by 2 plus a 4 sine 2x plus a 4 sine to the 4 of x. Next example. We're on page 3. So here you have x squared plus 2x minus 1 divided by x plus 4 dx. To find this integral, first do the long division. Long division. Why is that? Because the degree of the numerator is greater than the degree of the denominator. So here you will have x squared plus 2x minus 1, and you get x plus, you multiply by x, you get x squared plus 4x minus, subtract these two, you get minus 2x minus 1. So what do you need? You have a negative 2. You get minus 2x minus 8, subtract them, you cancel out these two, you get 7 as the remainder. So this integral is equal to the integral of, on the numerator, you have the product of x minus 2, x plus 4, plus 7, divided by x plus 4 dx. So what I did, I tried to write the numerator in somehow factored form, so eventually I can simplify this fraction. This is equal to the integral. I'm going to split these two fractions. I have x minus 2 times x plus 4 divided by x plus 4 dx plus integral 7 over x plus 4 dx. For the first integral, you can cancel out the common factors. This is equal to the integral of x minus 2 dx plus 7 integral of dx over x plus. So the first integral is equal to a half x squared minus 2x plus 7 ln of absolute value of x plus 4 plus constant of integration. Next example. Very well. This example says you have the integral of, let's see, you have dx divided by square root of negative x squared minus 8x minus 7. Perfect. So what do we have on the denominator? On the denominator, we have square root of an expression which happens to have exponent 2. So take this expression. Try to write it in completed format. So on the denominator, I have negative x squared minus 8x minus 7. Very well. If I factor out minus sign, I get x squared minus 8x plus 8x plus 7. I'm factoring out negative sign from all terms here. I have minus sign in front of, okay, let's see what do we have here. So you have x squared plus 2 times 4x, and I have 7 here. So b divided by 2 is going to be 4. 4 squared is going to be 16. So let us add and subtract 16 to this expression. You get x squared plus 8x plus 16 minus 16 plus 7. So here you have negative sign. Let's see what do we have here. This is x plus 4 squared minus 9. Now I'm going to just distribute the negative sign here. I have minus x plus 4 squared plus 9, or 9 minus x plus 4 squared. So my integral is now the integral of dx divided by square root of 9 minus x plus 4 squared. There you go. Remember that. If you have square root of a squared minus u squared, it's nothing but the inverse of sine function. So you can take u to be x plus 4 and du is just dx. So this integral is the integral of du divided by square root of 3 squared minus u squared, which is equal to inverse sine of u divided by 3 plus constant of integration, which gives you the inverse sine of u is x plus 4 divided by 3 plus constant of integration. Okay, another technique. We call this technique integration by parts. In general, if you have integral of u times dv, this can split it into uv minus integral v du. This method of integration is called integration by parts. So we identify u, we identify v, then we split the integral into the difference of u times v minus the integral of v times du. Let's go over one example to feel comfortable about this. Example. Suppose your goal is to find the integral of x e to the x dx. Okay, very well. I need to identify u. U is x, u is ex. What is dv? Is it just dx? So you have to try to investigate which one is the best selection for u and dv. There is no easy way. You have to check each other. So let's form a little table here. U, dv, du, and v. Okay, let me try. Let me try, say, okay, let my u be e to the x. E to the x. I'm trying to see which one is the best. E to the x, and my dv is x dx. X dx. So my goal is to break this integral down the way that I can get a simpler integral. If I take u to be e to the x and dv to be x dx, then my du, the derivative of e to the x, is equal to e to the x, and the integral of x dx is now a half x squared. Okay, so if I select u to be e to the x and dv to be x dx, based on integration by parts, I can rewrite this integral as uv minus integral v du, and this integral must be easier to solve. So what is u? U is e to the x. What is v? Is a half x squared minus the integral v du. I created something with a higher exponent inside the integral. So now I know that this is not a good choice for my u. This is not a good choice. Not a good choice. So I'm going to try again. I'm going to say, okay, now suppose I take u, v, du, and v. Now I'm going to take u to be x and my dv to be e to the x dx. The derivative of x is 1 dx, and the integral of e to the x dx is just e to the x. Now by using this choice, my integral can be written as uv minus integral v du. My u is x, my v is e to the x, minus the integral of v, which is e to the x, my du is dx. This integral is super easy to evaluate. Why is that? Because the integral of e to the x is just e to the x. So the answer is x, e to the x minus e to the x plus constant of integration. Integration by parts, trying to find the best choice for u and d. Another example for you. Integral of x sine x dx. Very well. We're going to use integration by parts and to try to come up with the best choice for u and d. U, dv, du, and d. So let us select u to be x and dv be sine x dx. Du, the derivative of x, is just dx, and v, the integral of sine, is going to be cosine x. Okay. So integration by parts say that we have uv x minus cosine x minus the integral of v du. V du plus cosine x dx, which is minus x cosine x plus the integral of sine of cosine is sine plus constant of integration. One last example for you. Suppose you want to find, example, the integral of ln of x dx while x ranges between 1 to 2. There is no other method to use. You have to use integration by parts. So let us form our little table here. U dv, then you have to calculate du and find v. Okay, since I have ln inside the integral and I don't know how to find the integral of ln, it means that I have to get rid of ln somehow. So suppose I take u to be ln of x and dv is just dx itself. So the derivative of ln of x is 1 over x, and the integral of dx is equal to just x. So using uv minus integral v du, this is equal to uv x times ln of x, 1 to 2, minus integral v du, x times 1 over x dx, x ranges between 1 to 2. So if you start to do 2 here, you get 2 times ln of 2 minus 1 times ln of 1 minus, then cancel out x and x. The integral of dx is just x. X ranges between 1 to 2. So the ln of 1 is just 0. You have 2 times ln of 2. 2 times ln of 2 minus 2 minus 1, which is using integration by parts to evaluate this integral.